Welcome to the Phonexia tutorial about how to evaluate our speaker identification technology. With our evaluation tool, you can easily test the performance of the technology with your data. In this tutorial, you'll not only learn how to perform the evaluation, but also how to understand the results and the performance metrics. I'll start this tutorial by going through the minimum hardware and data requirements, and I'll explain how to set up the evaluation environment. Then I'll present the recommended evaluation method and guide you through the interpretation of the results. And finally, I'll give you some tips on how to do the evaluation if you don't have enough data. To run the evaluation, you'll need a Windows or Linux 64-bit machine with at least one CPU core, with 8 GB of RAM and at least 1 GB of free disk space. We'll perform the evaluation in the Phonexia browser application, so please download the evaluation package by clicking on the link in this blog post. You'll also need an evaluation license. To get it, please send an email to info@phonexia.com. The correct preparation of data is crucial for a successful evaluation. I recommend that you collect data from at least 50 speakers with at least 4 recordings per speaker. Each recording must contain the voice of just one speaker, with a minimum of 30 seconds of speech. The system natively supports the WAV, FLAC and Opus audio formats. I strongly recommend to avoid lossy compression codecs. You can still use recordings in a different format if you convert them with a third-party tool such as FFmpeg or SOX, but remember that the results may not be reliable then. You can even set up Phonexia browser to use a converter in the background. I'll show you how later. The recordings need to be organized in a folder structure such that each speaker has their own folder. Let's have a look at an example dataset. I'll be using a set of 60 speakers with 4 or more recordings per speaker. You can name your speaker folders and recordings as you wish. There's no need to use systematic names that you see in the example. When you've prepared the dataset, let's move on to the next step. Navigate to the folder where you've downloaded the Phonexia SID evaluation package and extract it. Move the license file we've sent you inside the SID evaluation folder. Now the application is ready to run. Double-click the Phonexia browser executable. If you'd like to enable automatic conversion with FFmpeg or SOX, open the Settings window, go to the Speech Engine tab, and click the Enable Audio Converter checkbox. If necessary, you can click on the Configure button and navigate to the converter executable. You have to install the converter separately. It's not provided with the evaluation package. Remember to restart the server for the changes to apply. Now you're ready to press the SID evaluation button. In the Evaluation Set Management tab, choose Create New Set, and on the next screen, choose a suitable name for the evaluation. Specify the folder where you want to save the evaluation results, and navigate to your evaluation dataset. When you're done, press Validate. At this point begins the most time-consuming part of the evaluation process, extraction of voice prints from individual recordings. Depending on the amount of audio in your dataset and the power of your machine, this may take up to several hours. After a preliminary calculation, the system will indicate the estimated remaining time. When the voice print extraction and analysis are finished, a validation wizard will open. It guides you through the validation of your dataset in 8 easy steps. It searches for possible mistakes and lets you remove them from the dataset. If you're quite sure you have collected the dataset correctly, that means there's only one speaker in each recording, only one speaker in each folder, and no speaker appears in multiple folders, you can ignore some of the steps. In our experience, however, it's best to double-check the data with technologies. I'll show you an example and make recommendations on how to proceed in individual validation steps. In step 1, the wizard checks for recordings that don't have sufficient quality or don't contain enough speech. You can double-click individual recordings, verify them and remove them.
I think that when I started to sing songs like that...
Just right-click an item and select Remove. Some of the recordings can be discarded based on both criteria. so you only need to remove them once. However, in this step I recommend to remove all suggested recordings from the evaluation. By selecting them all, you can use the usual keyboard shortcut Ctrl-A and clicking Resolve Selected Issues. You can revert the deletions if you need to. At any time during the validation, you can go back and forth using the previous and next buttons. In all validation steps, the data is only removed from the working directory, not from your original dataset. In step 2, the wizard runs Phonexia gender identification to find folders that contain more than one speaker. You should individually check recordings with gender ID results which are below the threshold or which differ from the rest of the folder.
I don't know. Why doesn't Leone do that with me?
And a guest, he's the best.
Step 3 checks for multiple speakers in one recording. The stereization test can highlight multiple speakers if the recording contains samples with very different kinds of background noise. So I recommend listening to each recording and removing only those which in fact contain multiple speakers.
Never be accepted. I don't think Earth is in myself, in my subconscious. And when two of them, John Barry Ryan III, and but she.
We're very different places, very different countries.
Italian, and if you say the big three, if it's three syllables, not all the time. It was so wonderful at it.
In step 4, the wizard checks for duplicate recordings. These can either be completely identical, or one recording being a sample from a longer one. You can check individual files and only keep one instance of each recording. You can remove those that will resolve several conflicts at once. It's not recommended to cut one recording into pieces to fulfill the requirement of multiple recordings per speaker. Step 4 of the validation will often highlight this kind of data, so it may be useful to just select all files and remove selected items in one of the columns. This will solve all the conflicts and keep the unique files. When you click Show Removed Resources, you'll see the files which have been removed, together with the conflicting files that have been kept. Step 5 verifies if each speaker folder contains recordings of only one speaker. Step 6 is the opposite of the previous step. It checks if recordings of one speaker aren't present in two different folders. This way, you can identify duplicate speakers, as well as individual misplaced recordings. The system splits all multi-channel recordings into separate channels. In step 7, you can remove any possible duplicates created by the splitting if you didn't remove them in step 4. In step 8, the system informs you which speakers have been removed from the evaluation because they have fewer than 2 recordings. If you're left with very few speakers, you can still continue with the evaluation, but keep in mind that the results may not be reliable. When the validation is complete, you can lock the evaluation set and proceed to results interpretation. Remember that when you log the evaluation set, all disabled resources will be removed from your working directory and you won't be able to modify them anymore. In the results of the evaluation, you can see the out-of-the-box accuracy of the system with your data. The evaluation tool automatically creates a report that you can open in a web browser or share with us if you'd like to discuss your results. I'll use the graphs window now because it helps to explain certain points more easily. To understand the results, it's important to realize that the system can make two kinds of error. The difference can be best explained with the help of the PDF plot. In the right part of the plot, you can see a histogram of scores that the system returned for all the same speaker comparisons, that is, the comparisons of files within one speaker folder. In the left part of the plot, you can see a histogram of scores that the system returned for all the different speaker comparisons, that is, the comparisons across folders. The vertical line in the middle is the threshold based on which the user would decide whether two recordings belong to the same person or not. Setting the threshold correctly is one of the crucial steps in most implementations of the Speaker ID technology. Now, the first type of error happens when we compare two samples of the same person but the system says they are different. It gives them a score below the threshold. We call this a false rejection. These are all the scores which belong to the right histogram but the left of the vertical line. The other type of error happens when we compare samples from different people but the system says they are the same person. The score is above threshold. We call this a false acceptance. These are all the scores which belong to the left histogram but are right of the vertical line. To evaluate the accuracy of the system as a whole, we need to look at both errors at the same time. Notice that the proportion of the errors changes when I move the threshold. You can see the proportions in the yellow box. While one error rate gets smaller, the other necessarily grows. The system calculates the error rates for all possible thresholds and shows them in the so-called detection error trade-off plot. Again, you can see that by moving the threshold, I increase one type of error and decrease the other. At a certain threshold value, both errors have the same frequency, the so-called equal error rate. This is a frequently used measure of speaker ID systems that you will find in most evaluations. In my example, the equal error rate is around 2.2%, with the threshold at around 1.9 log likelihood ratio. What does it mean practically? Imagine we have 1,000 telephone calls with unknown speakers. We also have 10 known speakers as suspects in our database. If we compare all the unknown recordings with all the suspects, we'll get 10,000 comparisons. Let's say that in 100 cases, one of the suspects is actually talking in the unknown recording. Let's call such a comparison a target comparison. The remaining 9,900 comparisons are non-target or different speaker comparisons. Now the equal error rate 2.2% means that 97.8% of the target and non-target comparisons will be correctly identified by the system. It also means that 2.2% of the target comparisons will be falsely rejected as if the caller was not in the database. In this case it would be 2 or 3 comparisons. And 2.2% of the non-target comparisons will be falsely accepted as if the caller was in the database. That will be around 218 comparisons. So in the end, the system will suggest just 315 comparisons out of the original 10,000 for further processing. It's important to realize that these are not 315 phone calls that would have to be processed. These are 315 combinations of the incoming phone calls and the suspected speakers. It's probable that among the 218 false acceptances will be some of the phone calls where another suspected speaker will be correctly identified. So the number of phone calls that the system will suggest for further analysis, for example to be listened to by a human operator or for automatic transcription, will in fact be smaller. What's more, the equal error rate threshold is generally not used in real speaker ID deployments. Phonexia speaker ID evaluation can be used to find out the threshold that will best suit individual use cases. I can easily find the threshold value at which I will only get 1% false acceptance rate at the expense of increasing the false rejection rate somewhat. In my example, if I set the threshold to minus 0.8 log likelihood ratio, the false rejection rate will be 4%. That means 4 target comparisons will be falsely rejected, and the false acceptance rate will be just 1%. That is, 99 out of the 9,900 non-target comparisons will be falsely accepted. The rest of the comparisons will be classified correctly. So in the end, the system would only suggest 195 comparisons for further inspection. Again, among the false acceptances there will possibly be some phone calls where another suspect will be identified correctly. So the number of phone calls for further analysis is likely to be less than 195. Let's now have a look at a dataset that doesn't contain enough data. In this example, there are only 28 speakers with 2 files each. Even though the equal error rate of 2.7% may still look good, there are several ways you can tell this dataset is not okay. First of all, the PDF plot shows us clearly that the histogram of the same speaker scores is not continuous, so the Gaussian curve is not a good representation of the data. The results may not be statistically reliable. The lack of data can also be seen in the detection error trade-off plot. The false acceptance and false rejection rates can only be calculated for a very limited range of thresholds, and the curve is very crude and ragged. Just compare it to the full data set. Not only is the equal error rate higher than in the previous example, but also the equal error rate threshold is farther away from zero, which, together with a higher log likelihood ratio cost, would indicate that the system is not well calibrated for this kind of data. Also, the false rejection rate 10.7% at 1% false acceptance rate is more than twice as high as it is in the full dataset. Again, this incorrectly indicates that the technology is less good than we actually find out with the full evaluation set. So, what can you do if you don't have enough data to do a proper reliable evaluation? In that case, you can simulate a real speaker identification process in Phonexia browser. In this way, you can collect such a database from the audio that you do have, and while doing that, you can do some basic tests of the speaker ID so that you get at least an impression of what accuracy you might measure when you build your larger evaluation set. Start with creating speaker models that represent individual known speakers. Right-click in the Speaker Models pane and select Add New Speaker Model. In the pop-up window, specify the speaker name. Then click the plus button next to the Files frame and add any number of recordings of the given speaker. Click OK. You have just created your first speaker model. You can also import all the models at once. You should use mono recordings with the voice of just one speaker, which together contain at least 20 seconds of speech for each speaker. When you have uploaded all speaker data, select all the models and press Prepare Models. The system extracts the voice prints in the background. In the meantime, you can upload the recordings that will simulate the incoming data in the real process. Click the Add Files button and select the recordings. You can use any number of different speaker recordings for this, while mixing in a few recordings of the known speakers you created in the preceding step. Make sure that you use different recordings than those you used to create the speaker models. As the files are being uploaded to browser, you can see that recording quality and speech length in each audio are automatically analyzed. Note that recordings with quality lower than 50% or with less than 7 seconds of speech may not give reliable results, so they are disabled by default. Make sure that the Speaker ID technology is active in the top ribbon. Deactivate Gender ID and diarization. They are not necessary for this test and they would only slow down the processing. And click Start. Browser now compares all recordings in the list with all speaker models. This may take a while depending on the number of files you uploaded. After the analysis is finished, the results are displayed in the speaker score column. You should see the recordings of your known speakers getting significantly higher scores than all the other speakers. To make this easier, you can sort the recordings by their score by clicking on the column header. The best matching speaker model is shown together with the score, which is expressed in percentages, 0 meaning no match and 100 meaning full match. As you can see, Phonexia Speaker ID technology has correctly identified all the target speakers in my recordings, except for those which were not processed due to low quality or not enough speech. In the real environment, you would set a threshold based on the SID evaluation and mark all recordings with scores exceeding this threshold as containing the target speaker. You can use Phonexia browser to easily create new speaker models out of unlabeled data and collect the dataset necessary for a full evaluation. Remember that all these results are provided by Phonexia Speaker ID out of the box. When implementing our technologies, we train our clients on how to calibrate the system so it performs best with their own audio sources. In case you're interested in getting more useful information from your audio data, At Phonexia, we have a complete portfolio of voice biometrics and speech analytics technologies. If you'd like to discuss your evaluation results with our specialists, learn more about calibration or any other of our technologies, don't hesitate to contact us at info@phonexia.com. Thanks for watching.